If you're watching this video, it's because you hate mechanics. And quite frankly, I do too. And that's because mechanics, whether you're studying it in maths or in physics, it gets annoying. It's long, it's arduous, there's equations out of everything, and it's just not a very fun time. But luckily, there are some things that we can do to be able to make this a little bit easier for ourselves, make us not necessarily enjoy it, but certainly do better at it. So, first question you may be having is, why are you sat down? Well, because I want to, and I'm tired, and it's been a long day, and I don't really need the whiteboard. This is just going to be a quick video kind of introducing us to basically the 4 things that I say you need to bear in mind when studying mechanics that will hopefully make it easier. From this point onwards, I'm going to start making mechanics videos covering kind of pre-university and university content at some point, if I can be bothered. But for now, I just want to go through some ideas that if you're already studying mechanics will help you out. Now, what I'd like to preface this by saying is there are lots of different, nitty-gritty things of mechanics. If you're watching this, it might be because you're studying one of these mechanics, right? Your bare basic A level. Or maybe you're going along with these, some further mechanics. Maybe you're a physicist, or maybe you're in university studying something horrible that looks like this. But in all cases, no matter how specific and how difficult it has to be, there are 4 key things that you need to bear in mind that I will guarantee will get your marks up. So let's start with the first one. The first one, hopefully you can see this, is, I'm just going to call it the sign. And this is the thing that I find confuses students the most. And it used to confuse me the most as well. It's a pain. What do I mean by this? When is something negative? When is acceleration negative? When is displacement positive? When do I use speed or velocity versus speed versus velocity? What direction is everything working in? The answer to that, it's up to you. And that's something that we need to kind of get our heads around. This idea that you pick the direction you are working with. What I say to my students is the first thing you should do in a mechanics problem, one of the first things, is determine which direction is positive. Are you moving positively to the right, or are you moving positively upwards or downwards or to the left or backwards, or what dimension are you in? Whatever. Right? The direction really matters because it's going to change things when you're doing SUVAT, and it makes your acceleration negative when your displacement is positive, and vice versa, and it's a pain to work with. So you choose and keep it consistent. If you say right is positive, anything moving to the right has a positive velocity. Anything accelerating to the left has a negative acceleration, etc., etc., etc. So that's the first one, and that's important. The second one that everyone is going to hate is diagrams. And everyone's going to hate this because everyone hates drawing diagrams. Draw a graph or a diagram. No, I don't want to. Well, that's on you, because drawing diagrams is incredibly important in mechanics. It allows us to visualize what's going on and map things out so much easier. If I have a ball traveling through the air, it is much easier for me to draw a nice little diagram, label where it's going, what's happening, what direction I'm going in 100% of the time. If I'm doing a center of mass problem, much simpler again, just draw a diagram, work out what's going on. These things are realistic, we can visualize them, so just draw them out. Doesn't need to be arty, it doesn't need to be hung in the Louvre. It just needs to get the idea across. It's not for the marker's sake, it's not for the examiner's sake, it's for your sake. If you manage to write things out properly and draw it with a nice diagram that you can understand, screw what the examiner can understand, it's what you can understand in the diagram, it is going to help you. And this kind of leads on to my third point, which is, I'm just going to put real life. The reason I'm putting real life is because the one positive about mechanics is it is real. Everything that you're doing in mechanics, you can visualize in real life. The way that a ball falls out of the air, right? Or the way a car moves. Not only is this beneficial for drawing diagrams, it's also beneficial when we're getting our answers. We should be able to kind of know what the speed of a car is going to be. If we get a speed of a car that's 3,000 meters per second, something's gone wrong. But it's not only in big cases like that, it's also just with a ball. We can think about real life and what is happening with this ball. When I'm throwing it in the air and having it come back down, what is happening to its velocity? Visualize it. Pretend you've got it with you. Zero velocity gets thrown up and it's going to get faster and faster and faster, slower and slower, and eventually stop in midair and come back down. And we can think about it knowing it has to stop in midair and come back down. And that's something so important that everyone always forgets. This is happening in real life. We can visualize it. We know how a ball moves. We know how a golf ball moves through the air. We know how a car moves and how a plane flies. We know these things. We should be able to use them. And that's kind of ties in with the diagram. The fourth thing is that it is usually a lot simpler than you think, which I know is, a bit annoying to say, but by this what I mean is it's not usually as complicated as you think. If we have a ball flying through the air, yes, this ball has got momentum and there's air resistance and friction and all these different things happening on it. You've got gravity and you've got the force in my throw and you've got all of this nonsense, right? But when we're breaking down these problems, especially problems pre-university and early university, it's usually going to be about one thing. What do we care about? Do I always care about the air resistance, the momentum, the gravity, and the acceleration, and all of this in one? Or do I just care about the energy? Usually I do. Or do I just care about the momentum? Usually I do. Maybe I link one or two together, but in all my years, 10 years maybe of doing mechanics, pretty much non-stop, I can't remember the last time I saw a problem that had energy, air resistance, and power in it. 3 in 1, right? At most, it's going to be 2. And that's something that we need to start thinking about. Think about it in real life and just think about what is probably the 1, maybe 2 things I need to focus on. Is it energy? Is it momentum? Is it acceleration? Maybe combine them, but don't go any further than that. Don't end up with a whole page of power, energy, momentum, air resistance, etc., etc., etc. So these are my 4 kind of rules for learning mechanics. And for the next, however long it takes, I'm going to be going through videos detailing how to solve mechanics problems and going through things like that using my kind of 4 rules here. But I think that's pretty much all I had to say on the matter. I'm probably going to end this before I end up dropping this ball because I've overdone my amount of catches.